Welcome back, students, to video on Chapter 15. I'm reminded as I record this video how much I enjoy the interaction and being with you in the classroom, and I really miss that. I've been asked several times in the past years if I would teach online only courses, and I've declined. To me, the interaction between the students is what makes this the most fun for me, and I do really miss not being with you. So, Chapter 15, I have gotten a couple suggestions that have said, hey Scotty, could you open the slide deck and show the slide deck at the same time you go through the video? Great suggestion, but I got to be honest, I'm not the technical guru of the world. I don't have the equipment to do that here that I'm aware of. And so open the video, go through the slide deck at the same time. Hopefully we can work through this process together. We've only got a little bit left here. So Chapter 15, the slides are online on D2L. We're going to talk about material requirements planning and ERP, enterprise resource planning. Materials resource planning, MRP, is extremely critical, especially the larger the organization, the more complex the operation system is. And so we're going to spend a little bit of time here in Chapter 15 talking about it. It's used to manage a dependent demand, and it's dependent because of things like a master schedule or a parts explosion or a bill of materials are driving requirements in the materials resource planning, the MRP system. Typically we call them a push system because the master schedule is pushing information, constantly changing the requirements from that MRP system. So we go on to slide number 3, kind of a complicated graph. It shows the complexity of what's going on inside of an ERP, MRP system. Lots of things going on, and we're going to talk about most of these elements, if not all of them, here in the next several slides. So moving on to slide number 4, the MRP elements, we've got the inputs. We've got the master schedule, typically the bill of materials, the inventory records, all of the things that are feeding information in as we're doing our planning and scheduling within the MRP system. The outputs are the capacity plan. How much can we actually get done with the raw materials and the resources we have at hand in our system? What does purchasing need to do? And what does the shop floor control look like? What are we going to run? When are we going to run it? Now you see in the bottom of that slide in purple, it says needs to be accurate. I can't emphasize that enough. I've talked about it all semester, but it's a time now for us to talk about it even a little bit more. It's extremely important that all of the elements within your MRP, ERP system are extremely accurate. And we're going to talk about this more later in the chapter, but your inventory is correct. Your bill of materials of what you need to build parts is accurate, has the right level of parts, the right level of scrap, production rates. All of those types of things are extremely important as we talk about them. So as I move on to slide number 5, MRP example here, we're going to, excuse me, we're running a shop and we're building a simple table. Table's only got 4 components to it. The top, the legs, there's 4 legs, but they're all the same leg. There's 2 long rails and 2 short rails, and those 4 main components make up this table. So as we move on to slide number 6, what does the bill of materials, the product structure look like for this table? We have the table, the end item, and it takes us a week once we have all those subcomponents done, all the legs and all the rails and all the tops. It takes us a week to put all of these components together. We also need to make leg assemblies, which takes a week, and within that we have another week of doing short rails, and we need 2 of them. Long rails, we need 2 of those. And then the legs, we need 4 of those legs, as the bill of materials tells us. And of course, we only need 1 top, but that takes us 2 weeks to put that top together, to laminate all the pieces together and to sand it and varnish it or whatever type of finish is on the top of that table. So moving on to slide number 7, you'll see an indented bill of materials like this quite common in an ERP, MRP type system. At the high level, at the level 0, is the top finished table that would be sold to your customer as an example. 1 level below that is the leg assembly. To make the leg assembly, tucked in with that is level 2, which are making short rails, long rails, and legs. And at the same upper level assembly as the leg assembly on level 1, we also are taking a level 1 top. So the level 1 top and the level 1 leg assembly come together in the level 0 top assembly and make that finished table that the customer is going to purchase. As we move on to slide number 8, This slide here has a complex system, and this is what your MRP ERP system is going to be doing for you. That's why it's so important, excuse me, you have a good system, because having what you need to have on hand, when you need to have it on hand, what is the demand, the gross requirement is the on hand gross requirement on the third line, the 200 in week number 4, the 150 in week number 5, and the 600, the 100 in week number 6 is the demand. And down below it, based on the lead time of getting components and putting the subassemblies together, this is when you need to have things happening. So week number 1, we need to have all of the inventory on hand so we can put together for week number 4 sales what needs to happen there in the sense of inventory. Moving on to slide number 9, we also have materials and plans for the high level 0 and the high level 1, which the slide number 8 was for level 0 and 1. This is the second level of things that we're going to need to put together for those finished tables. Slide number 10 is the material plan, and this is again in the 2 slides that we just talked about already. The gross requirements for tables are on level 0. Those are finished tables going to the end. Gross requirements in level 1 for the tops. We need to know when we need to plan orders, when those releases are actually done, when we're buying materials, when we're going to have an inventory on hand. Then moving to slide number 11, that drives us to a master schedule that is coming from all of those different product families. These master schedules are usually frozen within production, so all parts can be obtained. Now for me, historically in the past, as we're working with MRPs, ERPs, they were typically frozen at least once a day. And for us, typically that was in the middle of the night. While everybody was sleeping in our factories, the ERP system, of course, being a computer, never sleeps. And in the middle of the night, it would generate all of the requirements from the previous day's system, and it would lock down once a day, and it would give us what we needed for forecast and master schedule and procurement, and the quantities we needed, all of those types of things. That again would happen once a day. Moving on to slide number 12, bills of materials. They are structured and they list all of the parts and materials that need to be consumed to make that finished good that you're making. Bullet number 2, they've got to be 100% accurate, and they need to be. If, as an example, you need 4 legs to make that table that we've been talking about, but your bill of material only says you need 3 legs, every time you set up an order, every time you start an order, every time you purchase, you're always going to be 1 leg short. Now, if you have a big, huge inventory, it may not at first matter, because if you go to the inventory shelf and you pull 4, but the bill of materials only says we're supposed to have 3, you're not going to know. But at some point you're going to run out of inventory because your bill of materials thinks you're only consuming 3 at a time, but in reality you're consuming 4. There should be a bill of material for every product per customer. Now, what do I mean by that? Down on the bottom of that slide, you're going to see that I have in my past career where we've made the same exact part for 2 different customers. Give an example. We make a little widget and we sell that widget to Walmart. We sell the exact same widget to Target, except for perhaps the packaging. Perhaps one of the packages says Walmart on it and the other package says this is a Target good. And so we would create a bill of materials to a sub-level, but that final part that got final labeling, final packaging, final invoicing to the customer, that would be a separate part number for Walmart and a separate part number for Target, even though inside of that box it was the same exact thing. Also keep in mind, especially if you're in a regulated industry, you can't just make changes to bill of materials because you wanted to with a snap of your thumbs. You've got to have things controlled, and typically for us in controlled industries in the past, we've used things like engineering change orders or ECOs. So every time a bill of material was going to be updated, several people would have to sign off. Head of production, head of engineering, head of quality. So all of these different sets of eyes would make sure that that bill of material was accurate. So as we move to slide number 13, inventory. Our inventory records have to be, again, very accurate. We're going to have a item master data segment that's got part numbers, costs, it's constant information. Inventory status by segment, or what materials do we need for each part. Then we're going to have data segment, which is information on outstanding orders, demand history, that type of thing. What do we have coming in from the vendors? What have we used in the past? Those types of things. Now, these records have to be 100% accurate. If your inventory system says you have 100 parts on hand, and you schedule to convert those 100 pieces of raw material to 100 pieces of finished goods, assuming we have 100% yield, no scrap. But when you go to that inventory shelf, because you only needed 100, and the inventory system says you have 100, and you go to the shelf and you find out there's only 95 on the shelf, that your inventory was 5 pieces short, you're not going to be able to fulfill that customer's order. And now it might be too late to get those 5 extra pieces you want. So the inventory has to be 100% accurate. Now, one way to do that is cycle counting. And with cycle counting, what you do is you do a physical count of a few items every day. So that all items are counted on a regular basis. In my history, when I've done this in the past, typically it was done on an off shift. And somebody in our inventory control department would create a list that would be given to this counting person, and it would tell them the part number. It would tell them where they're going to find it. It would tell them lot numbers, but one thing it did not tell them was quantity. And the biggest reason we didn't tell them how many was because a lot of times we were counting stuff that was in tiny little bags. And there'd be like 10,000 washers in a bag. Well, I'm in inventory control. I don't want to count this. So when somebody tells me, oh, there's 10,000 in that bag, I look at the bag and I go, I don't count 10,000. Well, there's 10,000 in the bag. Well, if we don't tell them how many are supposed to be in there, then they have to go through and they have to actually count them. We've used cycle counting in the past to hit driver inventory accuracy system from less than 75%. So if you can think about it, 25% of the time that you go to the inventory shelf to get something, it isn't there. 1/4 of the time. Not a good record, is it? We actually drove through cycle counting our inventory accuracy up to 99.5% accurate. In fact, we eliminated year-end inventory needing to do that because our accuracy of our inventory was so good. So as I go to slide number 14, capacity planning. The purpose of this is to aid our management, our leadership, our operations people in how much capacity do we need and can we schedule everything we need. I've talked to you many times during the semester about the 80% production rule. Whenever we get to 80% of capacity, we're already too far. There's 2 ways to do it. We can do shop loading, where we assign work to work centers. I've talked about this in the class before. You got 10 machines in a work center, and instead of assigning it to machine number 1 or 2 or 3 or 10, we just send it out to the work center and we let the setup people and we let the operations people within that cell decide which of the 10 machines are going to run it on. That's fine as long as all 10 of those machines are identical. Also, there's finite scheduling where you consider each resource. So instead of going to machines group of 1 or 10, we literally would assign this job to 1 and this one to 2 and this one to 3 and this one to machine number 10 all the way through the cell. That's what finite scheduling is. As we talk about slide number 15, purchasing is greatly enhanced by the use of the MRP system. In general, it's going to help eliminate your past due orders. Expediting will be reduced, if not completely eliminated, because if you have a good, accurate master schedule, it's going to look back at those material lead times, it's going to look back at your inventory system, and it's going to tell you when you need to order it. So you know what you need to order, you know when you need to order. You can, if you have forecasting built into your MRP, you can provide your suppliers with reports of planned future orders. If you have blanket purchase orders like we talked about earlier in the semester, then your suppliers can build to their convenience, hold it in stock, and then send it to you in a more expeditious manner. Or you can use electronic data interchange to move information back and forth. As we look at slide number 16, shop floor control. A good MRP ERP works terrific for shop floor control, releasing orders to the floor, managing orders for on-time completion. If you've got accurate lead times for your conversion time in the machine centers, prior to that, how long does it take to get raw materials? Prior to that, when should I order those raw materials? it can really, really help to create your orders, and your on-time delivery can be improved. Helping set job priorities. We talked about this earlier in the semester. First come, first serve. Priority customers get it first. Your ERP system will help you understand what the priority of the jobs should be so they all get started and end on time to meet that customer demand. Managing your lead times, minimizing inventory. Again, if you have a good, correct bill of materials, if your inventory is correct, your MRP ERP can help you drive inventory costs down. That extra inventory is one of the 8 wastes we talked about at the beginning of the semester. It can help you save money and time. A good MRP will help you understand, should I carry safety stock? It's going to help you through order history, through delivery history for on-time delivery. And if I'm going to have safety stock, how much do I think I should need? What is the lead time I should have? What is the capacity, the safety capacity I should have? I can couple it with my downstream distribution requirements, or upstream to give suppliers visibility to schedules. We are struggling right now with the virus. Lots of people are shut down around the world. Lots of manufacturing organizations like Cirrus Aircraft, the one that I work for, is struggling right now because we didn't have very much safety stock. Now, when you're talking millions of dollars of inventory, how much safety stock do you want to have? And could you have predicted the impact that this virus has had on the world and the catastrophes that it's caused? But this will help you. A good MRP will help you with safety stock. Slide number 18. To have a successful MRP or ERP system, got to have good implementation planning. You've got to have IT support. Good ERP, MRP systems have constant IT maintenance. They are not just an install it and walk away. So you've got to have it. You've got to have accurate data, good management support, and everybody that uses the system needs to have a good understanding, knowledge of the system, all the way down to your operators. If your operators are punching themselves in and out of jobs for labor reporting, if they're reporting finished goods and scrap and quality issues, they need to know how that MRP system works. Now keep in mind, a full MRP ERP system typically out of the box costs $2 million plus. They aren't cheap. Now when I say out of the box, there typically then is a lot of customization. In my past history, you're talking 18 months to 2 years of customization, and take that $2 million purchase price and double it by the time you customize it. So you're probably looking at an overall investment of $4 to $5 million for a good ERP system that is going to take care of a large enterprise. Then as we go to slide number 19, we've been talking about MRPs. ERPs are the same thing as an MRP, but they extend, and they basically, a good ERP system is what I would call from cradle to grave. A complete ERP system is also going to have pre-sales events in it. So for cold calling and lead management, and then once you found a good customer, the order management, creating quotations, getting purchase orders from the customer, entering those purchase orders, making sales orders, then going through and doing procurement, and then doing build. You're going to have quality in there. You're going to have quality records, things like calibration, preventative maintenance in a full ERP system. It's all in one system. On the back end, for those of you that are in finance, the whole finance picture comes directly out of the ERP. All of the billing, all the job costing, all of the month-end close activities, it all comes out of the ERP. So that's why I say it goes from cradle to grave in a full system. Probably two of the biggest global suppliers of end-to-end ERP systems, SAP, Oracle. Big companies, very expensive. Slide number 20, the last slide in this chapter 15 deck. Again, the ERP is a complete cradle to grave, as I said a moment ago. Starts with a quote, goes all the way through everything, including some of the things I hadn't talked about. Human resources can be in there. Shipping and receiving being a part of it. Inspection, building, raw materials, everything can be a part of that system. Again, short video on 15. Hope you enjoyed it. As always, reach out if you have any questions. Take care. Hope everything is good for you and your families. Bye now.